Hello and welcome to lesson 2 of week 19. In this lesson, we're going to look at Python generators. My name is Mildred. When we looked at collection types, we saw how to traverse through a list using an iterator that gives us access to each data element in the list. So refer back to your week 12 lessons to see how we did lists and sets and dictionaries and tuples, and how we looked through them using the for-in statement. And in the last lesson, we looked at how we use yield to create a generator, and we're going to look at all of that concept in the concept of generator. A list is an iterable, right? We say for I in those lists, we want to do something. The I is the iterator. So the iterable that we have an iter and a get item method, and it returns an iterator. The iterator has the next method, and then the iteration that we do is the whole process of taking one item from the list. Generators are iterators, but they do not store all of the value in memory. The values are generated on the fly. And what this does is it just helps us use less resources. Let's look for an example that might not make so much sense, but it makes sense when it gets to when we are calculating large sets of results and we don't want to allocate memory for all of the results at a time. Let's say I want to create a generator. I'll say def my generator, and I want the generator to take, let's say, an item, and then I will say for generator in a range item, I want it to yield I. Let's try to use this. Let's say for I in item, let's not use range item here, so that we can see how to properly use it. So let's say for I in item, we want to yield I. So let's now try to use it for item in my generator, and let's say the item now is a list of items 1, 2, 3. We want to print I. So this way, it is going to iterate through all of these numbers, and then it's going to print it one at a time to the page. Now, like, this doesn't really show us the good effect of a generator, except when we now start calculating large sets of results. Let's say you are given a task to calculate the Fibonacci sequence, and we know what the sequence is. It's like when the next number is gotten by adding the two numbers before it. And so let's try to create that function. It will make more sense for generators. So let's say here I want to do def, let's do the Fibon n. Now what this does is we want to have a sequence of numbers. For instance, I'll put a comment here for you to understand. We have a number from 1 to 10. We want to take, or 1 to 100. We want to take all of the Fibonacci sequence or numbers from 1 to 100. The first number is number 1. Second number is gotten by adding the last two numbers, so it will be 1 plus 0, 1. Third one is gotten by adding 1 plus 1, 2. And so that's why we get all of these numbers. The fourth number is gotten by adding the 2 before it. So all we need is two numbers, A and B. Let us allocate A to be equal to B. Let's say A is equal to B is equal to 1. So we can do it in different ways. And we want to say, let me use a for loop instead of a while loop, but that is also correct, but I want to change it. So I want to say for I in range n, so for I, that's going to be the iterator, in a range of numbers that we're going to supply, we want it to yield A, which is the first letter that we do not know. And then we want it to have the two variables A and B, which are the two numbers before, should be equal to B. So A will be assigned the value of B, and B will now be A plus B, so the two numbers before it. So this is the logic, and then this is going to print out that sequence of numbers. So let's say we want to now use this function that we have created to now print out the first 10 Fibonacci sequence. And so we'll do for x in fib10 print x. And when I save this, I'll clear and run. I'm going to print them out 1 to 55. So this is the first 10. So we have the first 10 printed to the page. So this is how we use generator, and this takes less resource. There's another way we can do this without using generator or yielding anything. So once you see yield, we are creating a generator method. We can do this by saying A is equal to B is equal to 1. So this is the same thing as saying A is equal to 1, B is equal to 1. But at this point, you should be familiar with writing variables as a comma separated list if their values are the same. So A is equal to B is equal to 1. And then we now decide that we want to create an empty list called result. And we also want to say for I, you can use a while loop, but let's use a while loop here so that you can get used to using a while. So while A is less than 100, so we want to have the numbers between 1 to 100. So let's say y is less than 100. We want to append the result. We want to append a to that result, and then we want to say the value of a should be b and the value of b should be a plus b. So it's similar to the last one, but I'm using a while loop. And so when I clear here and I run, we're going to have that. So I'm not printing yet, so let's return, or let's print results, and I'll run, and I have here. So what I have here is the first 11 numbers that are less than 10. Okay, so this is another way, but this is resource intensive, not like when we have a generator that yields, and it's what it does now, it gives you the results on the fly. It doesn't like the other one, the values are not stored in memory, you get it on the fly. So this is what the generator is all about. So whenever you want to write your code, you want to write codes that are optimized, you want to recall the use of both context managers, decorators, generators. And this is where we end this lesson. Thank you, and see you in the next lesson.